Alright, welcome to the fourth tutorial of the series how to make a basic 2D game, which is Trex Runner. Now, in this tutorial, we are going to spawn the obstacles, which are some thorny trees. In order to do that, open sprites, obstacles, and we have many obstacles here. Select this. I already made this. Okay, put it as multiple, sprite editor, and select these objects like this as I've shown to T-Rex thing. Select all these obstacles like this. These are large obstacles, and select the small obstacles in a similar way. Right? We have all the obstacles here. Let's consider these three and these three. We have 6 obstacles. So now we have to make a quad, which is a 3D object. Quad. Okay. First, remove the mesh and add a component which is squid, squid, and which is, let's name it as obstacles. That's it. Open the squid. Okay, now first of all we need to make this quad to spawn any one of these 6 obstacles. So let's create an array of game objects and create a transform which tracks the position and scale of something. We need to track the position of camera first. Okay, in the start we have a function. We need to make a function which is obstacle maker. Void obstacle maker. This is our own function, not predefined. Right. All we have to do is just call this function obstacle maker here in the beginning. Alright. In this obstacle maker, we have to create a game object, which are clones. Game object clone equals to instantiate. We are instantiating something, which is a game object. So set of game object. So which is a game object, and we can select 0. This gives the first game object. If we select 1, this gives second game object. 2, third. We have 6 game objects. So we have to get these game objects randomly. So what I do is random dot range. This is from 0 to ob.length. We don't know how many obstacles we have. We may have 7 or 8. As we know 6, we can put 6. That's not a problem. And comma vector 3, which is position. We can put like a transform.position or transform.position, comma. This is quaternion. Identity. We don't need any rotation for this. Okay, this is for rotation. Okay, and now we have to name the clone as clone.name equal to, let's name it as a quad. Okay, and we have to make, like, see what happens is, and we can invoke this, but we need to make float xx equals to random dot range let's take 1 2 5. We need to invoke the same function in the time interval of xx, which is a random between 1 to 5. So we are invoking the same function here. Now see, must be dot identity. Right. Let's see what happens now. Clear, but 17. What's wrong with this? I'm sorry. This must be converted to game object. I forgot this explicitly. Alright. Let's clear these errors. That's it. I think so. But we got another one. 20. Okay. This must be an quotations. Now we got no errors. Alright. Thank you. Let's. Okay. Before we play the game, we have to do something, which is create a new folder in assets, which is prefabs. Oh, sorry. Create a new folder. Prefabs. Inside the prefabs. Okay, before that, go to obstacles and select all the obstacles and drag them here. And these 3 obstacles, 2 and 3. Alright, go to prefabs and drag all of them into this folder. I'm sorry, each of them. Okay, and now we can just remove this, and we need to mention the size of the obstacles here, 6. That is the size of this array. Okay, we can drag and drop all these obstacles from here directly onto this quad. That's why I made it a prefab. And this, did I miss something? This one. Alright, let's see how it goes. Shamsian, I'm sorry, what happened is we have producing the same quads, and the quads are not box colliders, and the quad is produced at the same position. Every quad is produced just here, so we need to make some corrections in the code. Open this, and what we have to do first is, I'm sorry, I forgot, this quad must be a box collider in order to trigger something, which is, I'll tell you, box collider. I'm sorry, we have to remove this mesh. Remove component. Remove component. Oh, what happened? Okay. Physics 2D. Box collider. Alright, let's keep it like this. And transform. Okay, alright. We need to make the same. We need to make the clone to have a box collider, so clone dot add component. add component box collider td close brackets, right. And we need to have clone dot get component box collider 2d dot is trigger, which must be true. This is a trigger. When T-Rex touches the squad, the game must be over. So we need to make this trigger and all these clones. So let's save this and check this out. What happens here is it's creating quads which are clones and having each trigger through here. And the problem is the quads are placing on the same position forever. So we need to move the position of quad for each time. So we are taking the reference of camp position as public transform campers, and we can write them in a update function. Before that, we need to destroy the quads which are not used. So we can just first write the transform thing. Transform.translate. If you remember in the second tutorial, I have made a player prefab for the speed of T-Rex and the camera. I'm using the same thing here, so it must be equal to the camera, comma, which is vector 3 dot right into player prefabs get into dot get speed dot time dot into time dot there's time dot time. Alright, now the quads are moving. See, it places new quads in different positions as the invoking time is between 1 to 5. You can see them here. See, each quad is placed differently. Alright, and now we have something to do, which is increase the quad size. Of course, we cannot see them, and let's put it this way so the quad is visible. Alright, and scale it up like 4x4, and put like this way. Let's check this. Okay, this is kind of ridiculous, but what's happening is we have the sizes of these like 1 by 1. So let's select all of these obstacles and increase their size by 4. Okay, 4 by 4. Alright, let's check it now. It's look pretty good if these are placed somewhat below, like this. Alright, it looks fine. Fine and fine. Alright, we can decrease this its size to 3 so that the collision may be smaller. It's going fine now. Alright, and we have to increase the jump height. Firstly, it's jumping too low. Let's put it as 10 and check this. Oh, it's too high. Let's put it as some 7. Okay, whatever. It's fine now. And we have to destroy all the unused obstacles. Like we can see now, the objects are created one after the other until we play. See, quads are going to be created forever. This wastes the game memory, so we need to remove the game objects after it exits the camera view. So we can use the camera position now. So game object cs, which is game object dot find. This finds the quad. Sorry, this must be capital one. Alright, game object dot find something which is quad. That's why I named all of them quad. It finds a quad. It finds a quad. If camera position in the x-axis minus cs, the position of the newly found quad is greater than like 25, then it must be destroyed. I mean, it is out of the camera view, so it is no longer needed. We can destroy it. So this works for destroying. Let's see. This is not working because it's finding itself. So let's rename new clones as squad 1 and let's try now. This is working. This obstacle will be minus. Yeah. Okay, now we need to detect the collisions with the quad so that we can end the game. In order to do that, we can write another script on Trex. New script. That's over. Game over. Let's open this in monodevelop. Right, we got this. Write the function void on collision stay 2D box collider 2D collider. Alright. Okay, now in order to detect collisions with quads and make this game over, we can write another script onto Trex, which is we can add a script, new script, which is over. As this Trex is a box collider and quad is also a box collider, we can have a trigger while on if the collider name is quad 1, as the clone names are quad 1, the game must be over. Technically, game over means making the game pause. Time dot time scale is equals to 0. Alright, let's check this out. Alright, when this is collided with the obstacles, the time is stopped. We can write game over there, and that means technically the game is over. We can print the game is over afterwards. In the next tutorial, we are going to learn scoring GUI. So stay tuned in.